So I think it's working right now. It's waiting.
Okay. So yeah. Where is my sharing screen? Just here. So welcome to the postmortem sharing session. I get a postmortem that's called network policy is not working properly in a cluster on Viking. I will probably just quickly share the postmortem. I need to change my screen, but let me do this now. So just quick overview on how it looks. Okay, so yeah, it was postmortem recorded on the August 5th, 2020. It was regarding a Viking cluster. And the first description of the issue was that the cluster that was updated from version 11.3.3 to 11.5.0 had some trouble with the traffic. And after some time, I find that the problem was actually regarding the network policies. The traffic didn't really work in the clusters where network policies was used. It was even tried to update to 12.0, but it didn't really help anything. It was really nice that there was already some kind of preliminary information that I could use, that the problem only occurs when the network policy, then from other namespaces is there, and you cannot access the service IP from the pod. So there was also a command that helped reproduce it a lot. One thing to mention at the start, I was not involved on the postmortem from the start. There was actually quite a long thread, a lot of people trying different things. I think I started working on the postmortem like 7 days after that, so there was already lots of information that I could use for my investigations. All right, let's go back to my presentation. Okay, let's go full screen. Can you see my screen now? Okay.
Yes, we can.
So what was the problem? So I just wanted to narrow down. So it happened on AWS, and it was in the node pool releases. It was version 11 something. It was what was interesting was only specific to some clusters. So if we had some clusters that happened on the same release version, it happened, in some there wasn't. There was one thing that was quite deciding if it works or not. That was the network policy, as the example was used then from other namespaces. I will show this network policy later, just to have an idea how it looks like. And the problem that was observed was that the service IP was not reachable from the pod. So if you want to access some service, it was mostly timeouting. And as I mentioned, the issue was already investigated by several people, so I get a little bit easier job. And so this is the network policy. It's quite simple. I think this is example from one of the website that you can download. If you not cert, oh sorry. The namespace is scoped to the namespace. Sorry, network policy is scoped to the namespace. So this one basically just match all the pods in the namespace and make sure that only traffic inside the namespace can reach them. So pods from other namespaces cannot reach other pods in different namespace. And yeah, I was testing it through a running crawl command in the pod. So kubectl exec that's sticking the crawl in one of the pods, and this was the IP on one of the services that I was testing. So it was so easy to reproduce quite, so it was nice and really helped testing the whole thing. So the timeline, I work on this postmortem. First of all, as I mentioned, I wasn't the first who really started working on it. So I take a time and read all the information that was posted and think about it. Because it probably wasn't something super easily founded. It was something maybe a little bit more deep in the cluster or configuration, anything. So I started to read all the information and think about what could be the problem. One of the important factors that I was thinking about was that there was a difference between cluster where it works and where it wasn't. We knew that on the same release version in the customer, it was not working, but in our cluster that was created in the testing installation, it was working, even with all the things that we inserted and tried to reproduce. So there was something different. Then when I was like trying to figure out what's the difference, I went to the customer cluster and mine cluster actually in the same version and tried to reproduce the issue with creating the network policy and running the curl from one of the pods. And I try lots of things, not just like this running it from pod. I also try running it from node. I also tried running it from different nodes, same node, master, and so on, and see like maybe a little bit narrow it down or nail it down. Where's the issue actually? If it's like only from the pod or something else. But the result, what I remember, was mostly always the same. That it didn't work from the pod, but it worked from the node for some reason. Then, as I had all this information, difference between the clusters and so on, I jumped on the node and wanted to check maybe the difference between the node and the cluster resource. As you know, that basically we use the cluster resource as source of the information for rendering and creating the cluster. But there are known cases, at least I remember, that it's not always 100% correct. So you have CR that defines one information, and then you find something else on the node. So that was also something I tried to do and try to find what's right and what's wrong. And this was the step where I actually make some breakthrough and find something useful. So I was checking the CR and I was looking for the CIDR pod or CIDR block, how we defined it here. And that was one network defined. And when I was on the node, I was actually looking for the easiest way how to get this CIDR block from the node, and I know it's somewhere in the kubeproxy console. I basically look on for this information, and I found that there's a difference. They are not the same. So okay, this is not right. There's something wrong about this. It's maybe partially random, but yeah, I was basically trying to find the differences. And when I look on these two CIDRs, I realized that one of them is actually the default one we use for the installation, and the other one was the value that was the cluster actually using. So the important thing about this was the customer clusters were using custom pod CIDR and not the default one. So that kind of show me that probably we don't render it right. That's the whole. So as a quick test, I went on the nodes, changed the configuration for the kubeproxy there, and basically I saw immediate result that the command started to work. The curl was no longer timeouting and then traffic was fine. So I identified this as like, okay, this is the root cause of the issue. And now I need to go a little bit backtracking to see how it happened and why it's rendering wrong. So what was the root cause? As we already know, as I said, it was the wrong CIDR block here, setting on the kubeproxy. And yeah, I was thinking why this was actually happening here or now. What could be the problem? And why it happened only with the network policy? That's also like interesting thing, because if it was like, if you set it right or wrong at some point, I would expect that you will notice it at some kind of testing. But the problem is that in the IP tables is quite complex chain. If certain rules are not always hit, and if you don't have network policy, then it will just like end permanently and reach the endpoint without any problems. But when the network policy is applied, then the IP, or basically the network that's set by the kubeproxy, is quite important there, and it will lead the traffic to the right place. But it wasn't happening because the network was wrong. So this is only happening for customers with the custom pod CIDR. And when I go a little bit deeper, I found that it was introduced during a migration to the new TCP control plane stack that we did. We also, because we changed a little bit how we render the ignition templates, and the custom pod CIDR that we introduced was set properly for masters, because that's important, because the CNI, AWS CNI or Calico, whatever is, need to set the value right. So we had it right on master. The cluster was created the right CIDR, the pod were on the right CIDR, but we had it wrong in the worker. We were using actually the default value. So we forget to set it. So default value was used instead of setting the custom. And they was only basically found because of this bug, because there was no other problem with the traffic, which was kind of interesting to think about. Anyway, so yeah, I found out that the problem was there, so it was super easy to fix in the AWS operator. I set the right value there, and tried to create cluster, and yeah, the problem was not reproduced anymore. So the root cause was basically wrong rendering of the ignition. So I fixed that quite for the worker nodes. And what was the lesson in here? I think there are a few things to consider. One thing would be that, yeah, we need to improve the testing with the node default use cases for our customers. That's basically, we test quite basic setups. We don't test the network policies. We don't test maybe some external load balancers, this kind of thing. So yeah, adding this to our.
Yeah, we lost you. No.
Hello. Okay. For some reason, my headphones turn off if there's no sound from the headphones for a long time. So sorry, but I already know this. So yeah, introduce more tests like this, network testing, basic network policies, and make sure the traffic works. That's something that we really need to make sure in the future, so we don't need the same problem again. Another thing that was quite interesting was for me that maybe as I reading the postmortem, lots of people were going really deep into the IP tables rules. And I think that's one of the things that not always is worth to go that deep into the Calico and kubeproxy, because the chances that there's a bug that's happening only on one cluster, not all of them that we are using, is really small. And it's, for me, it's impossible to read the Calico and kubeproxy IP tables rules. That's just like super mess. The counters are resetting often, and it's like not really easy. So I think one of the important lessons here is rather look at the input that goes into such components rather than the massive output that it generates. Because if somebody would rather check the kubeproxy input, then he would see that, okay, the range is wrong. So I think that's something nice to think about when you're debugging such issues or such postmortems. And yeah, that's basically it. It was a little bit quicker because yeah, I think I didn't really work that much. Lots of people working on that already solve or investigate most of the things for me. Do you have any questions regarding the postmortem?
Yeah, but I think was a great one. Yeah, and you were really define all the steps. So I really like it. I have a question. I think I was checking the proxy configuration in newer clusters. Could be that newer clusters doesn't specify anymore the pod size.
Yes, in the new ones with the new configuration of CNI, it's not there anymore. Present is not required. I think it's like either deprecated or something like that. I know. So defining the wrong was causing the issue, and if you remove it, it's actually fixed. So that was also kind of weird.
Okay.
Yeah.
Cool. But we still define the slice of the pods in the kubelet flag when we run it.
I'm not 100% sure from memory. I think no, because the kubelet actually gets that information from CNI configs, which like Calico CNI or AWS CNI will put it on the node, and kubelet is reading from that file. So I think in the ignition it's probably not anymore, at least. Yeah.
Okay. Okay.
Yeah. There is one thing to mention. I like made an appendix. As I started like before doing some recording of debugging session for Free Firecracker, I did basically live debugging of one of the postmortem. I think that was quite, at least I can enjoy it and maybe useful from other things. And I think it would be nice to have place where such things could be placed. I'm planning a second one to do soon. And I was looking at the shared folder. I couldn't find any good place. So maybe we can think about some folder where we can put all these recordings, and I was also could put mine as well, so other people can see it.
Yeah, I created one folder in, I think, SIG ops processes, which is called PM sharing sessions or something like that. I can add it there if you want.
Okay, I can find it there. So it's, which folder is it? Like 6 and 6 ops process?
6, yeah, I think so.
Okay. All right.
And this recording, this recording will be there.
Cool. Okay. Yeah, that's links only. That's the link to the postmortem. I don't have anything else to link here. And yeah, that's basically it.
Okay. I don't have more questions. Nick, do you have something?
Yeah, maybe one thing regarding the IP tables. Like I wonder, like, would it at some point would it help if you would just like instead of you using the IP tables, would it be better to use the IP virtual server because it's just like more readable or so? I mean, wouldn't this like be like more helpful in a way that you could just like figure it out more easily, or was it just like at any point not really related to IP tables or anything like that?
I don't know, to be honest. I mean, IP tables now currently it's like mess, and I think the kubeproxy, they have some other different modes, but I'm not think if the rules are privacy going to be the same, if there's no way how to virtualize the information somehow without seeing where the traffic actually goes, I think that's like super hard to like know what's happening. And there are thousands and thousands of rules, so find it there, it's like hard. Even if there's like, I think there's like IPVS, yeah, this one. I think that the rules and routing it's going to be similar like to this. So I think, yeah, without the virtualization, it would be super hard. Maybe somebody can read, but for my head, it doesn't really compute when I really look all the rules. And it's like, because it's usually one chain and you jump into another one and you jump like through 10 chains. And it's like, okay, maybe it's going to hit here or not. Yeah, I think that's hard.
Yeah, I think you don't have any visualization tool
Yeah,
or something like that.
like, if you can somehow say, okay, I have traffic from this spot to this spot on this port, and show me how it goes, that would be really nice. Like, and you can see, okay, it hit here because, and then you can investigate the rule. Maybe there is something, I don't know.
Yeah, Pau the other day found that one of the Vodafone clusters has like 1,300 network policies. So it's really hard if you need to know what's happening.
Yeah, exactly.
Okay, cool. So yeah.
Okay, cool.
Again,
I think we can stop the recording, so it's
how I do
done.
That? No, stop recording.